The International Space Station, ISS, is a joint project of 5 space agencies: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA, Canada. It is a habitable artificial satellite that orbits Earth in a low Earth orbit at an altitude of approximately 408 kilometers, 253 miles, above the planet's surface. The ISS is the largest human-made object in space, with a mass of approximately 419,725 kilograms, 925,335 pounds, and a total pressurized volume of about 931 cubic meters, 32,816 cubic feet. It is about the size of a football field, measuring 108.5 meters, 356 feet, long and 72.8 meters, 239 feet, wide. The construction of the ISS began in 1998, and it has been continuously inhabited by rotating crews of astronauts and cosmonauts since November 2000. The station serves as a unique research facility in space, where astronauts and scientists conduct experiments in various fields, such as biology, physics, astronomy, and technology development. The ISS orbits Earth at a speed of approximately 28,000 kilometers per hour, 17,500 miles per hour, and completes one orbit every 90 minutes. Astronauts aboard the ISS experience 16 sunrises and sunsets every day. The ISS has several modules, each with specific functions. These include the Russian segment, the US segment, the European segment, and the Japanese segment. The Russian segment includes living quarters, life support systems, and communication equipment. The US segment includes research modules, the cupola observation module, and the robotic arm used to assemble and maintain the station. The European and Japanese segments also contain research modules and support equipment. The International Space Station, ISS, is a complex structure made up of many different components and modules that were built and launched by several space agencies over a period of many years. Here is an overview of the main components of the ISS. Zarya module. This Russian-built module was the first component of the ISS to be launched in 1998. It provides propulsion, electrical power, and storage for the station. Unity module. The Unity module was launched by the U.S. space agency NASA in 1998 and is the connecting node between the Russian and U.S. segments of the ISS. It contains docking ports for other modules to attach to the ISS. Destiny module. This U.S. laboratory module was launched in 2001 and is used for a wide range of scientific experiments. Zvezda module. This Russian-built module was launched in 2000 and serves as the living quarters for the cosmonauts on board the ISS. It also houses life support systems, communication equipment, and the docking port for Russian Soyuz and Progress spacecraft. Columbus module. This European-built laboratory module was launched in 2008 and is used for a variety of scientific experiments in biology, physics, and technology development. Kibo module. This Japanese-built laboratory module was launched in several stages between 2008 and 2009 and contains scientific research facilities, a robotic arm, and an airlock for external experiments. Canadarm2. This Canadian-built robotic arm is used to assemble and maintain the ISS, as well as to assist with scientific experiments and spacecraft docking. Truss segments. These large, U.S.-built structures form the backbone of the ISS and provide support for the solar arrays, radiators, and other equipment. Solar arrays. The ISS has 8 large solar arrays that provide electrical power to the station. The ISS is constantly evolving, with new components being added and old ones being replaced or upgraded as needed. Despite its complex and constantly changing structure, the ISS serves as a remarkable example of international cooperation in space exploration. The International Space Station, ISS, serves a variety of purposes, including scientific research, technology development, and international collaboration. Scientific research is one of the primary purposes of the ISS. The microgravity environment of the space station provides researchers with a unique platform to study physical, biological, and chemical processes that cannot be observed on Earth. Scientists conduct experiments in fields such as medicine, biology, physics, chemistry, and astronomy to gain new insights into how these processes work. The ISS also serves as a technology development platform. Astronauts on the space station test and evaluate new technologies and systems that may be used on future space missions. For example, researchers have tested new spacesuit designs, life support systems, and radiation protection technologies on the ISS. Another purpose of the ISS is international collaboration. The project is a joint effort between 5 space agencies from the United States, Russia, Japan, Europe, and Canada. The cooperation between these agencies allows for the sharing of resources, expertise, and knowledge, and promotes peaceful collaboration among nations. In addition, the ISS serves as a testbed for future human exploration missions. The experience gained from operating the space station and conducting long-duration spaceflight experiments is expected to inform the design of future missions to the Moon, Mars, and other destinations in space. Overall, the ISS serves as a valuable resource for advancing scientific knowledge, technology development, international cooperation, and preparing for future human exploration missions. The International Space Station, ISS, has a number of internal systems that are essential for supporting the needs of the astronauts and cosmonauts living and working on board. Life support systems. The ISS has several systems that provide the crew with breathable air, remove carbon dioxide and other contaminants, and regulate temperature and humidity levels. These systems include the Environmental Control and Life Support System, ECLSS, which uses a combination of chemical and mechanical processes to purify the air and water on board. Communication systems. The ISS has several communication systems that allow the crew to communicate with each other, with ground control, and with other spacecraft. These systems include antennas, radios, and video cameras. Electrical power systems. The ISS is powered by a combination of solar arrays, batteries, and fuel cells. The solar arrays provide most of the station's power, which is stored in batteries for use when the station is in shadow. Fuel cells are used as a backup power source. Waste management systems. The ISS has systems that collect and process human waste, as well as systems for managing solid and liquid waste. These systems are essential for maintaining a healthy living environment on board. Health and medical systems. The ISS has medical kits and equipment to handle a variety of medical emergencies. The station also has a treadmill and other exercise equipment to help the crew maintain their physical health in the microgravity environment. Robotic systems. The ISS has a number of robotic systems, including the Canadarm2, which is used for assembly and maintenance tasks, and the Robotic Refueling Mission, RRM, which is used to test technology for refueling spacecraft in orbit. Overall, the onboard systems of the ISS are critical for maintaining the health and well-being of the crew and for enabling the station to carry out its important scientific and technological missions. The International Space Station, ISS, has crew on board requires constant attention and maintenance from ground control. Crew rotation. The ISS is staffed by a rotating crew of astronauts and cosmonauts, who typically stay on board for 6 months at a time. Crew members are launched and retrieved using spacecraft like the Russian Soyuz and the SpaceX Crew Dragon. Maintenance and repairs. The crew is responsible for maintaining the many systems and components of the ISS, including life support systems, communication equipment, and scientific instruments. The crew also performs regular inspections and repairs as needed to keep the station in good working order. Scientific experiments. The ISS is a platform for conducting scientific experiments in fields such as biology, physics, and materials science. Crew members conduct experiments on board the station and also remotely operate experiments on the ground. Robotics operations. The ISS has a number of robotic systems, such as the Canadarm2, that are used for assembly, maintenance, and scientific experiments. Crew members on board the station control these robots using joysticks and cameras. Communication with ground control. The ISS is in constant communication with ground control centers around the world, which monitor the station's systems and provide guidance to the crew. The crew also communicates regularly with family members and friends on the ground. External operations. The ISS is equipped with airlocks and robotic arms that allow crew members to perform spacewalks and other operations outside the station. These activities are typically carried out to maintain and repair the exterior of the station, install new equipment, or conduct scientific experiments in the vacuum of space. Overall, the operation of the ISS is a complex and challenging undertaking that requires close coordination between crew members on board the station and ground control teams on Earth. The ISS serves as a remarkable example of international cooperation and scientific achievement, and it continues to play a crucial role in advancing our understanding of the universe and our place in it. The launch and docking of spacecraft to the International Space Station, ISS, is a critical and carefully orchestrated process that requires precise planning and execution. Here is an overview of the launch and docking procedures for spacecraft visiting the ISS. Launch. Spacecraft that are bound for the ISS are launched from Earth using rockets like the Russian Soyuz or the SpaceX Falcon 9. The launch is carefully planned to ensure that the spacecraft arrives at the ISS at the correct time and in the correct orbit. Approach. As the spacecraft approaches the ISS, it uses thrusters and guidance systems to adjust its speed and trajectory. The crew on board the spacecraft monitors its systems and prepares for docking. Capture. The spacecraft is captured by the ISS using a robotic arm or docking mechanism. The crew on board the ISS uses cameras and sensors to guide the spacecraft into position. Docking. Once the spacecraft is in position, it is secured to the ISS using a docking mechanism. The crew on board the ISS checks the seals and pressure levels to ensure that the spacecraft is securely attached. Hatch opening. Once the spacecraft is securely docked, the crew on board the ISS opens the hatch and welcomes the new crew members on board. The crew from the visiting spacecraft enters the ISS and begins their mission. Undocking. When it is time for the visiting spacecraft to depart the ISS, the crew prepares for undocking. The spacecraft is released from the docking mechanism using the robotic arm or thrusters. The spacecraft then moves away from the ISS and begins its journey back to Earth. Overall, the launch and docking procedures for spacecraft visiting the ISS are carefully planned and executed to ensure the safety of the crew and the success of the mission. These procedures require close coordination between the crew on board the spacecraft, the crew on board the ISS, and ground control teams on Earth. Finally, the ISS is expected to remain in operation until at least 2028, and its future beyond that time is currently under discussion among the space agencies involved in its operation.